Hello and welcome to yet another interesting conversation with people from software development. And my guest today is a Swede who traveled all the way to the coldest part of France, and he's involved in the software craftsmanship, software craft communities there in the uh, conferences, and he's doing a lot of work for the community and with companies from the area and not only. And I like to welcome Johan Martinsson.
Thank you. Thank you very much, Alex.
So I think we first met. I don't remember when we first met, which is interesting because we keep meeting, and so it's like we've known each other for a long time. But I think it was one I take on conference, if I remember correctly.
Yes, perhaps. I think I met maybe Adrian first, and then it was due to I take. Not sure, but yeah.
So what I like to do in the beginning is to ask people about why you got into programming, what attracted you to programming, and how did you go to kind of where you are now.
Okay, so that's interesting because I have I think an atypical history with programming. Sure, when I was very young, I had a computer and I played a lot and I tried a bit of programming and so on, but it wasn't really a passion and I didn't go so much into it. Then I went to engineering school and I did electronical engineering. Was very interested in mathematics and kind of followed the course of mathematics. And I ended up in France for the last year of my studies because I wanted to ski. I wanted to ski in the Alps. And going to France was a good excuse to be able to ski most of the time. And when I finished that, I wanted to stay here in the Alps. So I needed a job. It was in 2000. There was no jobs available. Everyone was firing a lot of people. And I was looking for very special research work in mathematics. And there was just no way of getting any. A friend of mine was a computer engineer and offered me a job, and I took it. I was really not interested in programming at all at that time, but it seemed like a good opportunity. And doing that over the years, I discovered that programming was really, really very interesting thing. I could find everything I liked about mathematics and hard problems, complex situations. I could find that in programming. So the passion actually grew with the years to become very strong, and now I will never leave programming for the rest of my career.
So that's an interesting background because uh, on my side, I also like mathematics, but I also like literature, and I was writing a lot. And to me, it seems like programming has a lot to do with both of these domains. And so I'm curious for somebody who has been perhaps much more involved with mathematics. I kind of quit mathematics in university. It wasn't that so interesting for me anymore. It was interesting, like mentally, theoretically, but not something that I would be passionate about. Did you find that programming is very similar to mathematics? Did you find differences or?
No, I don't think it's very similar in many ways. Lest I would have discovered the passion very early on. More like I'm very attracted to complex problems. Small, kind of well-defined problems is really something I've liked for all my life. And programming has these small or big hard challenges that are, I mean, well defined if you compare to people problems and or management or whatever. So I think that's what got me interested. And what got me even more interested was discovering TDD and XP, etc., which actually makes programming a harder challenge, in the sense that it's harder to write code that will both run in production and satisfy tests and make that easier. So as it got more difficult, I got more interested.
All right, so I'm thinking about, I mean, I would expect somebody who likes programming, engineering to go into this area of test-driven development, and because it seems like it's more structured than what we, let's say, traditionally do in programming, which is fiddling with things. On the other hand, I noticed one big difference between people who have a mathematical background and people who come from, let's say, an engineering or software engineering background, which is in engineering, the first lesson we learn is that if you have a measurement error of 10%, it's fine. You can live with it. Whereas in mathematics, you need to have everything very precise and so on. And this maps to how they see like agile software development or test-driven development, or there's a need for precision on one hand. On the other hand, you could say, well, it's close enough. let's deal with it. I'm curious what has been your attitude in the beginning on this type of situations.
I think there are several driving forces in my passion for programming and my attitude towards everything in life. There is, of course, this interest in precision. And a while ago, I was very interested in the programming language Idris, which is a very mathematical programming languages where there is well, you can prove the implementation. It's provable. So that's very interesting and not always that useful. So there are useful things in that, and there are not so useful things in there. It's also quite immature, I think, but there is this passion for that. But there is another thing, another driving force, which is to make a situation work. I often like to warp between the details and the very, very large overview of the situation, the whole project, how it's going, how we're satisfying clients, and so on. And so that kind of brings me to a good balance, or at least a balance, in that I can take a step back and then see what is bringing value, what is useful here, and then there's always something interesting, useful to do, so you can do that.
Yeah, I think to me that's one of the most interesting parts of programming, which is you're kind of constantly discovering both the problem space and the solution space. You can kind of pushing in all directions at the same time. And to me, I've studied a bit the history of engineering because I was curious on what was the difference between this and sciences, for example. And as an engineer, if you build a bridge and it stays, it's fine. You don't have to understand the forces that. And that's how we build the first bridges. Now, it's good to understand the forces that you apply in the formula so that you can repeat the construction. But if you're just doing it once, it doesn't actually matter. Whereas in science, you need to kind of repeat that again and again. And it's and I find this, to me, software development is around this area where you kind of try things out, see if the bridge stays, and then move forward.
That's definitely something which is not out of traditional engineering. That's where it differs a lot from the other engineering principles. I think that's one of the difficulties I had when coming to programming. I'm much of a person who will think first and then act when I know what to do. which does not always work out in programming. Let's face it. Sometimes the best approach is just start doing something, and then you will know what to do. That's an approach that I had to learn. But now, after 20 years of doing that, it's a very natural part of me of starting to do something and kind of oscillate between thinking, looking ahead, and then doing to discover. I think we have these kind of personality types, but it's much more powerful what we actually do, what we train ourselves to do.
All right. So, how did you train yourself to think differently or to adopt these practices like TDD and refactoring?
There are the user groups that I joined as early on as possible when I discovered them. So that has helped a lot to discover these practices with other people, to open up mind to people who are working in different situations. That's a very important thing. So a lot of katas, a lot of coding dojos, and then a lot of katas by myself too. I've done a lot of that just for fun, and I'm very much of a person who will listen to what I think is fun to do. Because if it's fun, I have a lot of energy to do a lot of it, and I will eventually get fairly good at it. I don't push myself to do things that I don't think funny. I'll find another strategy for handling those areas.
So, what do you find fun in TDD or refactoring?
Oh yes.
Well, what makes it fun for you? What do you think makes it fun for you?
The coding problem in itself is a lot of fun. So solving challenging coding problems is fun in itself. What is fun in TDD? I don't think I have a good idea of what I think is fun in TDD. However, refactoring is a lot of fun. Refactoring is a lot of fun. And in TDD, you have a lot of refactoring. So maybe it comes a bit from there also. But I really like refactoring because in general, I like improving situations, which is probably why I'm very much of a coaching person. I want to improve situations, even whether they are human, project related, or code related.
Mm-hmm. So I have a hypothesis for what makes TDD fun, and I think it would be interesting to pass it by you and see if you have a different idea, perhaps. I think there's some gamification built into TDD. It's the whole idea that first I define a small problem for myself, which is the failing test, and then I have the green test, which is, suddenly something works and something more works than it worked before. And this brings you into a cycle that's very similar to what games do, which is, if you are, I don't know, if you play a role-playing game kind of game, you go out, hunt some animals or whatever, get some loot and get some experience point, and then you level up. And so you have this kind of loop built into the cycle. And I think, at least for me, this is one of the things that make it fun, combined with the idea of discovery. I keep discovering and exploring the solution space. Does it ring similar or true, or is this?
Yes, it makes me think of one discussion I had with the colleague once. There's this book called The Happiness Hypothesis, I believe, which basically states that you're happy in life by finding a lot of small joys. If you're looking for big joys, you cannot get a lot of them, and they don't bring you as much joy as many small joys. And at every green bar, you have a kind of happiness refill. It's okay, good. So with TDD, you kind of maximize these happiness moments. So yeah, I think that can definitely be true. Although it's true because it's in the long run. I think there's a reason why there's a lot of crappy code around, and it's for basically the same reason, because it's very much fun to see something work. Just hack something together, see it run, work, and then making the details work and managing that over time is not so satisfying. Of course, it can get a lot more satisfying if we practice TDD, so we can keep the good parts for a lot longer. So yeah, I think you're quite right.
But now the question is, and I'm asking you this because I know you are involved in also helping people adopt test-driven development and adopt these practices. And we know that this is a hard journey. It's not something that you do easily, particularly when you start with kind of the university training, which is first to define, or you have a completely defined problem, and there's one good solution to that completely defined problem, then you need to find that one good solution. That's kind of the mindset that I got in university around programming. So if you have people with this background and so on, so what were the challenges that you face when you try to help people adopt test-driven development?
Multiple. In the beginning, it was quite hard. When you see first, when you try to make people do TDD, is that there's a lot of resistance, of course. They continue as they've always done, and you can understand why, and so on. It doesn't seem logical, but people are not logical. And over time, I understood that people don't want to get practices pushed on them. And that's often what happens when you, I don't know, some developer comes and states, oh, this TDD, it's the only thing that works, and then you have programmers who have worked for several years and it's always worked for them. Or even worse, you have a manager who says that, okay, guys, since you're not doing TDD, I'm bringing in this expert programmer so he can teach you how to do that. It's deeply unsatisfying for people, and why doesn't all they've done for many years work? I mean, there's no reason for that. So it's there's a lot of resistance in that. And even when you're past that resistance, even when you have some kind of curiosity from people, then as you say, it's probably the hardest thing in programming to adopt, because for quite some time you feel like you can't program anything anymore, and that's very unsatisfying. That's not that doesn't bring you happiness, right? So there are multiple challenges in doing that, and it's not about teaching the method, it's about making it easier for people to make that big leap.
So how have you dealt with it in the past?
Well, in the past, first of all, I had this completely naive approach when I had just learned myself to do it, and I was on a project where we were that wanted to do it. It was easy because everyone wanted to do it. Almost everyone on the team wanted to do it, and it worked a charm. And then I went to other teams that weren't so keen on it, and I was kind of trying to push it on them, and it didn't really work, or it worked with some people, but it did not at all work with other people. And so as a whole in a team, it did not work. So, and then over time, I found different ways of dealing with that. And now I'm more like, how do we? So there are always good reasons why they don't already do TDD. Every system that has perdured for some time is a stable system. And a stable system is there because there are forces that are keeping it in place. So I approach it with, okay, so what are the forces keeping it in place here? And what can I do about these things? So one thing that is obvious is you give some training. You change the system because it becomes easier for people to do refactoring or do tests, or it becomes easier to do TDD. Maybe in some TDDing some pure functions become quite possible quite rapidly. So you do change the system in that sense, but there is more you can do, like change the system so that it becomes more appealing to do TDD. And I don't know if you want to go into the detail of that now.
Yeah, sure. I mean, just a few ideas around this, if you have a few experiences, because I think some of our audience is about, perhaps I would like to try, but perhaps they are not fully convinced to try. So then it's interesting to see some ideas on how other people have overcome these challenges fundamentally.
Yeah. So a while ago, I was interested in the movement of Bug Zero. I participated in that movement, which was a way of doing that. So you address the problem of bugs with whatever tools you have. It turns out that test and TDD is quite useful for that. And you can see some results quite quickly. So that's one approach. Now, very often I bring out continuous delivery for quite a lot of reasons. It's for one thing, it's sort of a proven method. It has proven results, which is kind of the only method in programming that has actually proven results. It's quite spectacular, but mostly because it's such a global thing. It's very, very easy to find a real business case for more frequent delivery. Mm-hmm. So going from 3 months to every 2 weeks, or every 2 weeks to every day, even functionally, people, POs and so on, are very interested in this. Even company owners are very interested in what this brings. And it kind of gives an overarching goal to achieve, which with whatever methods you want. And when you do that, one of the strong things is it becomes a problem to solve as a team, mostly by the developers, but it becomes a problem to solve. It's not a method to apply. No, they have to solve it with different things. So it's not only TDD, of course, it's monitoring, it's a lot of things. But it's very satisfying to participate in problem solving. Mm-hmm. And you kind of respect the intelligence of people who are there. They have a lot of experience and are quite creative.
Yeah. So who would have thought involving people in solving their own problems on how they work, not only on what they do, but also on how they work. That can work.
Yeah, and the problem is not how they work today. It's just that when you change the system, working the current way is not a stable system anymore. Yeah. It becomes unstable, so it will change in some way, and probably going towards where we'd like. But let's face it, we don't have complete control of that, and that doesn't matter.
Yeah, yeah, of course.
And so when you change that system, and at the same time you provide some training on some methods, then some get adopted very, very quickly.
Yeah. And the goal is never to do test-driven development. Is not well. It can be a career goal to do test-driven development. Perhaps it opens you to other possible job opportunities. But for a business, the goal is not to do test-driven development. Is not to do agile. The goal is to have some, as you said, some business goals to achieve some business results. And some of them can be achieved by continuous delivery and things like that. It links directly to that. So you mentioned participating to user groups on test-driven development and learning about these things with user groups. Were these, what kind of user groups were these? Were these software craft user groups? Were these XP user groups or general language specific ones?
So the first user group was the local coding dojo. I think it started here in Grenoble in 2008, if I recall correctly. And it's quite interesting because it was every 2 weeks, and it has continued to be every 2 weeks since that time. Now it's what, 13 years.
Yeah,
it's been.
Yeah.
It's there's not a lot of participants, but there's always a core team, and some people come, some people go, some people come back a few years later. It's a good time, and we've had the opportunity to do a lot of different things over those years. It's the kind of good example of regular practice, you know. That is always later.
Yeah,
so that was the first one.
So that fascinates me because when I first got into software craft, it was about mostly about code retreats, as you know. But we got a lot of inspirations from coding dojos. But it was quite late when I saw the first coding dojo actually facilitated by somebody who was doing this. It was Nigel Sleepy Fox, who we also had on this channel from London. And it's very interesting to see what a good atmosphere they were able to create there, and to involve people and to get them to try out new things, because that's fundamentally what happens there, right?
Yeah, and yeah, so that was not a software craftsmanship at the time. I think the term came a bit later, or at least got well known a bit later.
Yeah, coding dojos precede software craftsmanship. Yes.
Yeah, at least the word. Just wanting to do your job well. That's always existed, right? Craftsmanship is very, very old.
Yeah, I mean, like the movement.
Crafting is very old. Sorry.
Yeah. I mean the movement. Yeah, and so you're talking about this.
Yeah, and then what happened later was probably a lot of involvement in the agile conferences and the technical part of the agile conferences at that time. Also the not so many code retreats. We did participate in the very beginning of the code retreats here, and notably we had the first legacy code retreat in the world here in Grenoble. That's funny. But I think the population here that did that, we all had small kids, and we weren't very happy to spend our Saturdays doing that. So that was not did not continue that very much. So it was a lot of these agile conferences and a bit later developer conference. Still the same kind of activity of crafting content in the development conferences. And then presenting at conferences and stuff like that, that's also part of the involvement with the crafting community.
Mm-hmm.
A bit later, I discovered the Socrates conference, unconferences, and that was a really good concept. That is a really good concept, which I've attended a lot. And maybe then in the yet again a few years later, I was creating the crafting community meetup in evenings. It's still a local event here. And now, it's been 2 years ago, we decided to start a crafting conference. A conference completely dedicated to crafting and the crafters and developers in general, because we feel that this approach needs to be known a lot more.
Yeah.
Even the other day, I was shocked. I interviewed this person who was in last year in school, very passionate about programming, and in his school he had not done any testing, no automated testing, and he did not know of the word TDD, test-driven development.
Yeah, I mean, unfortunately, that's a common story, and I think it's part of the problem with adopting these practices, that we start by thinking that, once again, that we have very well-defined problems, which is not always correct. Because in reality, we are kind of discovering the problem at the same time with the solution. And
Yes.
And then we think that any well-defined problem has a clear and one perfect good solution, which is once again not correct, because it's you know a lot about systems theory, so that works in very simple systems. It doesn't work in complex systems. We kind of stumble upon various advantages and disadvantages of every solution. But I'm curious about another thing. So it's been, I don't know, more than 10 years since we have software craft as a movement. What does it mean to you today?
The software crafter movement?
Yeah.
I think one of the prime benefits of this movement is somewhere where people who have this wish of doing their job well and getting better at what they're doing, feeling not so comfortable with the kind of practices or how things are being done currently, they're a bit alone in their company. Whereas this community is a very good resource for these people to understand the problem better, to train themselves, to prepare themselves to do some things in a different way. I think this kind of support for change is very much needed.
Yeah. And I agree. I think one of the big gains of this movement have been the proliferation and how many communities you have in all the big cities in Europe, and where you can go around and kind of hang out with people who, well, at least we used to before the pandemic, and hang out with people who are interested in this and have the same goal, trying to get better, trying to learn more, and so on. On the other hand, I find that it's kind of picked these ideas that, you know, we have to do test-driven development and refactoring, and there are like a number of practices that we look at. I don't know, personally, I'm not satisfied that we don't go further than that. You know, probably know that already.
Yeah, yeah. At the same time, well, there are some in these communities. There are a lot of people who are trying to go further. So I'm not sure what you're dissatisfied about. There's also a lot of new people. So this, I mean, we cannot go only into more advanced things. There's a majority of people who are still eager to practice and perfect their skills in this area. But
Yeah.
perhaps you can develop that, what you're unsatisfied about.
Yeah, well, you know, so I like to look at things also from different perspectives and that software. So, for example, one thing that I would like to share more in these types of communities would be the history of software development. I think we are lacking on history a lot. It's not only that we don't know test-driven development, which is, let's say, a common practice, or perhaps not a common practice, but something that is known for some years. But you also have conversations like, you know, MVC is a new pattern when it's been around for 30 years or 40 years. I think in the 70s it was in Smalltalk for the first time. So history is a big, huge problem, and that's something that I would like to see addressed more. But it's a community effort; it cannot be one person effort because it's overwhelming. And then there are the various interactions with other types of like engineering. How do engineers work, and why do they work differently from software engineering? Let's say. Designers, how do they work in other domains? Why do they work differently from us? And I understand this is more complex because you need to look at various things that are not in the center of your attention, like, you know, writing code and having fun. But in terms of advancing the craft, I think these are all necessary things. And I'm pretty sure they will happen, but they don't happen as fast as I want to. Yeah.
Yeah. Well, yeah, you do a lot of these explorations with parallel concepts from other areas, and it's quite time consuming to do these things. It's for the person doing it, it's not a good return on investment usually, because there's a lot of things that are not useful. On the other hand, when you have people who, like you, are very interested in this and exploring these into detail, and then kind of condensing to what kind of value can there be in this, what can I bring back to the community, and what can I distill? That's the action that's going to please most of people. So.
Yeah, well, thank you. I do my best, but I think what I'm not doing so well is spreading the word. This is something that I've been pretty bad on. And one example, that's actually one interesting thing, because I know we have conversation about usable software design, and we have actually co-developed the concept in a way with the people from the software development gang group. Because yeah, I came with the initial idea, but then you did some of the work, and we coalesced an idea that is more that makes more sense, let's say, and that can be introduced to other people. And for people who are listening, just a quick introduction. The fundamental idea is to look at a software system as a design that is used by programmers. And if you look at a design that is used by programmers and they are users of the code, then you can apply usability principles on this design in order to improve some of the characteristics. And I know you've been very interested in this, and I'm curious because we never actually had the chance to. We talked about the concept, but I never had the chance of asking you what made you interested in that.
Yeah, it's actually the same thing over and over again. It's about transmitting these things to other people, and it helps a lot in that. The same thing as continuous delivery, same thing as bug zero, which we might talk about. It's this idea of so clean. We're doing clean code. It brings us things, or we're trying to do clean code, I would say, and it brings us things. But transmitting it to others there is this trap of pushing practices. You should make smaller methods. Please help. No, this is why clean code in a way. So it has to be usable. The code is the working tool of the developers that are passing after me. So yeah, it needs to be in good shape. And this is why. And you can often find yourself reviewing some code in the merge requests, for instance. If you don't have the luck to pair program on the code and you're reviewing it, then how do you deliver that code review in an acceptable way, in a humane way, or a positive way? It's very different to say that you should do this instead, from saying, okay, this code. So how easy will it be to remember what to do when you come back to this code? Or imagine someone new to this. Do you think there is a risk he might make a mistake? Is there an alternative design that would reduce that risk? Or we have three options. How well would they score against like learnability and error proneness and so on? And then you get a very constructive discussion. And yeah,
Yeah,
so that's.
I think this also started from because I noticed how people were arguing about design and about code, and it was often a lot of posturing, like I like this better, you like that better. It's never. It was always a contest of who's more powerful. Like, yeah, I will impose this way of thinking because I don't know, I have more experience or whatever, or we've always done it this way, or any kind of argument. And I think ideally you would have more thoughtful conversations about design and about code that involve things like this. So things like, okay, so this is something that a new person would understand better, and we know we need to hire 10 more people because otherwise we won't go as fast as we should, or everything you mentioned. So yeah, I think it was an element of having constructive arguments rather than posturing and power plays.
Yes, and they have this anecdote where I've worked with a lot of people who had a difficult attitude towards TDD or crafting. Probably that's where you end up working a lot of the time when you're into this, of course. But this particular person who had incriminated on a previous project, I learned this, of course, after joining the project, that the reason the previous project failed so badly was because they were writing so many tests. This was the architect who had just the initial solution of this new project, and he was known for writing 3,000 lines per night of ununderstandable code. There was a lot of difficulties in our two approaches because clean code was not a concept of his; it was working code, and test was not an option for him. It was a thing to avoid at all prices. And you want me to have the team do TDD with this architect? Yeah, and then you have to come to the, so what are the common grounds? What are the common grounds that can be built upon? So this is an intelligent person. It's a very good developer. Or like he knows a lot of stuff, and he can do a lot of things. Otherwise, he would not be in this situation. And what do we share? And there's a lot of things, and usable software design is very, very useful in this sense, because it brings us to why. And he's not happy when people are calling him 5 times a day so that he can explain his code. Or he doesn't have a solution to it, but it's certainly a problem that he feels, you know. And he was also not very happy when people break his code over and over again, and he has to help them fix that. That's not the kind of thing he likes, and that he doesn't want for the project. So these were the kind of common grounds that we could build upon, and so this project turned out very well. He discovered the use of tests, and he's not a TDDer, but he sure likes tests now.
Yeah, that's good to hear, because yeah, in fact that's true. And we discovered in our exploration that tests can be very helpful for usability for a few reasons. One is, if you have tests that you can easily read, you can understand what that code is doing without actually reading the code in some cases, because you can kind of see the examples there and infer from those examples what the code is doing, and also from the names of the tests. And so, and on the other hand, it reduces the chance for error, which is another thing that you have. You can change the code, run the test. Oh, it doesn't work. Go back. it's easy.
Yeah.
And I like the metaphor. I always use the impossible object that are. So I think we'll add a link to those, because those are really fun. It's like a designer who builds objects that are perfectly fine and nice objects, and they look cool and so on. And I think you can actually buy them, but you cannot use any of those because you have like a water boiler that will pour on your hand when you try to pour the water and things like that. So, and this shows how design can go wrong. Even if you follow, let's say, the clean code rules and so on, it can still go wrong by introducing possible errors in your code. Yeah.
One thing I learned before leaving the subject, one very important lesson that I was taught that I didn't expect through usable software design was, I think it was much thanks to your idea of user testing. Mm-hmm. So user testing, we're doing it on our applications so that user can use them to discover what the main pain points are. I used this a few times, and just sitting behind a developer who is using the code I've just written for the first time. I spent like half an hour doing this to see where he struggles. And it turns out that I learned that many times I write perfectly refactored code which has some really bad names. It's very easy to fix. The reason why they're so bad is because when I started on this code, it was the good name. And then I refactor. And it turns out it's not at all the good name anymore, but I don't see the name. Which is the exact reason that we don't see, as designers, we don't see the errors we're doing because we know too much about it. So we're not reading the name of the method, for instance. We have it here somewhere.
Yeah.
We have a pointer to it. And that's something which is utterly difficult to discover, even when you're reviewing your own code. But it's very, very easy for someone new to the code to review. And I learned to that a review from a trainee is worth gold. It's worth just as much as a review from someone else in this sense. And it's probably the most common and worst mistakes that I do in the code.
Yeah, and this maps to a problem well known in design, which has a name, but I cannot remember it right now. And it's this kind of blindness.
Yeah.
Because you see things every day, you're kind of blind to them. One common example that is known in the history of design in general is before iPods, you would have MP3 players. But when you got them from the store, the battery was empty, so you had to charge them before using them. And then a huge innovation was, let's charge the battery to like 75%, so that you can actually take the iPod and listen to it immediately. And this immediately changes the experience, but people are so used to that approach that they couldn't see the alternative as designers. So it's a very common story in design in general. And yeah, you fix it with feedback. You fix it with user testing. That's the general idea.
Yeah.
All right. So yeah, I know we had a lot of common points on this, but we also have some differences on strong type systems, and I think since this is a very common point of contention on Twitter, it comes up again and again and again, like strong types versus weak types. I think it would be interesting to spend a few minutes discussing this. You mentioned Idris, which is, as you said, you can write code that is already proven to be behavioral correct. So if it compiles, it works.
Yes.
Right?
Yes.
And intellectually, I find that very interesting.
Yes.
What attracts you to this type? And what do you think would be an advantage of this approach?
Well, I think it's a new tool. It's a new concept to manipulate. So, I mean, that's enough for me to be interested by it. Mm-hmm. And it's also, I very much like practicing in the extreme, mm-hmm. so that I quickly learn what is a good trade-off. You know? And of course, in this sense, if you want to learn typing, there is nothing better than Idris, because it's just the strongest type system probably around. So that's a good reason for being interesting. But I learned quite a lot of things through that, things that I do now that are useful. But what is interesting actually with a language like Idris is that I think mostly you can express the domain in a very abstract way. You can express the business rules in the type system. And so that gives a very, very high level of thinking about the problem. And you get a correspondence between this high level thinking that you can have a normal and the actual code that stays in the code. You know, we were all saying that we should make the code self-documenting. This brings this a step further. I don't know if you have to to make an example, correct? You can write types so that you cannot express a wrong date, like that there is no 29th of February on non-leap years. You can do this kind of thing. You can do, there's this kata called the coin change kata, where you have to give people change. They have bought something for 5 cents and they give you €1, so they have to give them back 95 cents. And you can express in the type system that the change will sum up to 95 cents if they buy something for 5 cents, or if they give you €1. So it's very, very powerful. And yeah, I like the domain expressiveness in it.
So I think just a quick mention, if there are any C++ programmers watching this, you can actually do the same in C++. And if you read the book by Andrei Alexandrescu, Modern C++ Programming, I think, I don't remember the exact name, but there's one famous book by Andrei Alexandrescu who talks specifically about how to use the template systems in C++ to build very strong type systems, which are, when you write the code and if it compiles, it's guaranteed to be correct. So you could actually do this. For me, it wasn't a new idea. I've seen it in C++ in the 2000s, something around that time.
Yeah.
But I think in Idris, well, I don't know Idris a lot, but probably it's easier to do the same thing in Idris than in C++ syntax-wise. It looks probably better than that it would look in C++. So this would be like the strongest type system that I can imagine, the one where you encode the rules, encode so fundamentally, if it compiles, it's behaviorally correct. You know it works.
Yeah.
And that sounds very good theoretically, except that those rules change.
Yeah.
So then what do you do? Because my big contention with strong type systems is that they impede changeability.
Yeah, I've heard you say that. Yeah.
I don't dislike them. I think they are interesting, but I think they slow down changeability. So what do you do if you need to add tax to your calculation on the change?
Yeah, so I mean, of course, this can happen. So the basic idea of these strong type systems, so specifically in Idris, it's called dependent types that depend on others, and we do kind of calculations, is that they're very easy to express, and so because you have to express something which is correct, otherwise the implementation is false, of course. You can kind of shift the burden to like expression easily, but then you have to make the implementation to make that pass. And it turns out that some problems were very easy to implement, but other definitions were almost impossible to implement. And it follows, of course, that if you have something which requires a lot of code to prove that it's doing what the types are saying, then if you want to change that, then there is a lot of code to change, of course. Which quickly brought me to a balance of how precise do I want to be. I might try very precise, but then I allow myself to loosen up things if it's too difficult to implement, and kind of think about what is the essence of things that I want to express. Yes, that's the thing I want to express, and keep only that. But one thing that I really learned through Idris is that we have to use small types. If you have big types, then any change to them might be enormous. And then what we want to do is we want to compose these small types. Types can be constrained into a more complex thing. And then when you have the change, then it will not ripple through the whole thing. It will touch some small types, and it will not be a huge change in that way.
Right, that makes sense. However, another thing that I noticed is you have these small types and you combine them into larger types and so on, and this takes you to higher levels of abstraction. You get to things that are difficult to name, to things that are, or have more abstract names. And it becomes a problem for people who are trying, in this case, to use your code to understand your abstractions and to manipulate those. This is something I noticed with trying to use a library in Haskell.
Mm.
And the first problem, I mean, I like Haskell. Haskell is a really nice language from my point of view. I kind of like how it's built and how it expresses things. But whenever you try to do something useful in Haskell, like, bringing in a library and things like that, then you need to spend a lot of time to understand the abstractions that and the language used in that library in order to be able to use it. And to me, that's another kind of impediment on changeability, because yes, if I'm changing my own code and I already know the abstraction, and that's fine. But if I need somebody else to use my code or to know it.
Yeah, I definitely see what you mean. I can have felt the experience sometimes, but I think it's an orthogonal concept. The kind of high level abstractions that you can find in Haskell is a way to write less code, but it's not quite the same thing as if you're taking a concrete example. If we're doing FizzBuzz, for instance, so it's divisible by 3, divisible by 5, and maybe divisible by both. I don't know if I need to. I probably don't need to explain FizzBuzz in this.
Yeah. No, it's fine.
Anyway, so you can do, in others, you can do a FizzBuzz type, which is then have this 3 and 5 concept. And then you change, so you introduce bang, for instance. So every number which is divisible by 7, it has to have bang. And then you get a problem because you have also, you don't only have fizz buzz bang, you also have fizz bang and buzz bang and I don't know, all the combinations. You actually add 4 situations, and so the type explodes. But you can also define a type fizz, being fizz or not being fizz, being buzz, not buzz, being bang or not bang. And then you combine these things. You can actually have both fizz buzz and fizz buzz bang in the same program. And then you have the type. You can have the type of fizz buzz being the assembly of the both. That's not a high level abstraction, which is difficult to. There's no genericity in it.
Yeah, I agree in this case.
Genericity is the problem.
Yeah, but then if you expect to add like 10 more things like that, then what you need to have is some kind of structure, some kind of type that has 2 of the types. Like a type that has fizz and buzz and represents fizz buzz, but can also have fizz and bang and represents fizz bang. And then how do you call this type? And that's kind of where it starts to get into genericity and more complex abstractions.
But that's an effort to write less code.
Yeah.
And factorize the code through genericity.
Yeah.
Which is a problem in any code base.
Well, not quite, because if I don't have strong types, then I can name something that has, I don't know, combination of these types, combination of fizz and buzz, combination of whatever. And I don't have to specify all the possible combination. You just can, it's an object. You put everything you want there. And as long as I have a name for it, which gives me the right idea, then that's absolutely enough. And that gives me enough genericity, enough without working too much to please kind of the compiler of the thing. So yeah, that has been my observation.
Yeah, I also like types, of course, because since they code more knowledge, the IDs tend to be able to help you a lot more.
Yeah.
And of course, in some languages, you don't have the ID to help you that much. Haskell is not very supportive. It could be very supportive, but it's not.
Yeah, and then you have C++, which has a very strong type system, but because it has so many variations, the IDs cannot. It takes a lot of work to understand all the possible combinations that can come up there. So,
yeah.
So it's quite weird when I tried refactoring in C++, things like moving a method to a class or things like that. It's no. There are so many variations of the syntax that it's quite difficult. Yeah. So but I agree with you. Types are very useful. I think they are very useful at the edge of the system for security, for validation. They are very useful for refactoring if you can have them. But to me, the ideal thing would be if the compiler would understand what I want to say. You know?
Yeah.
One of the things that I was very annoyed about, and I'm glad it goes away from many programming languages, is when you had to say, for example, list L equals new list of something. Why do I have to type list twice? You know,
yeah.
You know it's a list. Yeah. Get away from me, you know. And it goes back to the principles of usability, because they started from the idea of we shouldn't work for the machines. Machines should work for us. This was the Donald Norman's core principle when he talked about usability. So I'm not sure if it's possible, because I don't know enough about types or compilers. But it would be nice to have some kind of smarter inference on types.
Yeah. We can see this example. Elm, the Elm language, is very known for being very, very easy to adopt. And yet it's almost a Haskell, not as generic, of course, but it's very much like Haskell. And turns out that the error messages are extremely helpful, extremely usable. And so that's the focus on usability there, as and the strong types being a means of the usability is a very successful combination. I think Haskell didn't have that focus. It's a scientific language. A lot of people are in that because they want to push their mental capacity a bit further. It's very pleasing to try to do advanced types, and I can imagine that some libraries are kind of more than sufficient. You know, like I have experienced with more than necessary generic code in my past. I needed to experiment with it, and then it turns out it's probably not that usable by people who are using it today. So I think that the types are not the problem. I think that the genericity and exploration might be the problems, and lack of effort on the usability side are the problems.
Something that I learned from a conversation on Twitter is that types introduce some rigidity into the system. They also introduce a lot of useful characteristics, but they introduce a certain rigidity, and perhaps you need to introduce the stronger types or get stronger and stronger types once you understand and once your knowledge on that part of the code kind of coalesces and it becomes clear and you are fairly sure that you got it right. Maybe some kind of progression would be useful there.
So what you mean is you reinforce the types as knowledge kind of stabilizes.
Yeah.
Yeah. I think you can do that, but on the other hand, as knowledge stabilizes, the code stabilizes, and it's not going to be changed that more. So the types might be less useful at that time.
Yeah, that's true. There's always a trade-off. All right.
Yeah.
So I think we could discuss much longer on this, but it's uh, I think we touched on a few interesting points, and it's good enough for me. And if anybody is interested from the audience in this conversation, I'd be happy to bring more people to debate strong types versus weak types. It's something that's quite interesting to me right now. So one thing that we touched in passing was about the domain, and I know you've been involved in also in domain-driven design somehow. What do you think is most useful from domain-driven design today, and what are people using?
I think there are two areas. There is some things in the detail and some things in the very large and very abstract. It's very, very clear to me that if you look at the Conference of Domain-Driven Design Europe, it's a lot of abstract things. It's a lot of things that help you think about your system and draw your system and put it in different angles of view, involve a lot of people in it. So it's completely a toolbox of architecture, and the strategical part of domain-driven design is doesn't really have a competitor in a way as a method. So that's clearly very, very useful. Now the actual, we associate domain-driven design with a lot of the Blue Book and how they implemented repositories and aggregates and so on. It always helps a lot to think about things in ways that were not formalized before. So what is a root aggregate? So what is the boundary of something that we can update in our database in a cohesive manner? That was not really formalized, so I didn't encounter it before. But me including, a lot of people didn't get that part of it. Now it seemed like a lot of prescriptions of how to organize your code into repositories and services and so on. Whereas I think the value is a lot of in the thinking tools, and those thinking tools are very, very useful in whatever code base.
Yeah, I found domain modeling and the idea of thinking about the domain in the center to be like the most important part of this, and it's quite useful. But I have I have to challenge them from time to time that they think too much about design upfront.
Yeah, I don't know. Maybe you can explain that, because it's not because you have the tools, good tools to do it, that you have to do too much of it.
Yeah, no, I agree. But there was, I mean, it's a very valuable tool, and the idea of domain-driven design, I think, is very valuable, and I think it's where most of the interesting conversations about design are now. I wish there were also other places and other views, but it's definitely where, if you're interested in software design, I think this is where you should look at. There's a lot of good people involved there who know a lot about software design. I know Rebecca Worsbrook is an active part of these communities, so that's already saying something to me. And
there's another useful part, I think, which is not so much talked about, and which is not exclusive to domain-driven design, but the idea of small details in the code being linked to domain concepts and being named in that way, and being modeled in that way. So you can write some code which badly models a domain, and if you do that, you're gonna have a lot of bugs because there's a lot of illegal transitions that don't become impossible.
Yeah,
and the natural transformations are not so natural in the code. And I think that I often say that domain-driven design starts in the small, which is not true when you start a new project, of course, but it's where most of us developers, we have a lot of possibility to improve things every day. We can extract a new type which groups 3 strings together, which domain models domain. We can replace some switch statement with a map, and that map becomes an object which has some methods on it and expresses the domain in a completely different way than the 3 switch statements that were in all over the place. That's not the blue book, but to me it's very much domain-driven design, and it's very close to the values that we can expect from domain-driven design, which is easy to understand, usable code, and bug-free code.
Yeah, and I completely agree. It's definitely worth checking out and getting into this area, because for many large applications, for many business applications, makes a lot of sense to have these connections and be able to have a conversation about the domain model with people who don't know programming and express the same things in your code instead of using 2 different languages, let's say one for the code and one for domain experts. All right, this has been a very interesting conversation, and I'd like to move to closing it. Before we close, I have a couple more questions. First one, is there anything that you'd like to share with our audience that we haven't talked about? Perhaps a book that you like, or perhaps an event that you would like to check out, or something like that.
Good question. Well, there's a lot of books I like, but I bought a whole range of these books, to give away to people I work with, because that's one of the best books on why continuous delivery and what kind of results they've had in research, and I think it brings a lot of good, and it's only like 100 pages to read or something. So yeah, this book is a warm recommendation. Accelerate.
All right. Second question. I like to ask this since we have very experienced practitioners on this channel. I like them to give back a bit of advice to people who are just starting in programming. So imagine somebody who is new at programming, a junior programmer, or perhaps in the first few years of a job. What would be a piece of advice that you give to them?
Well, one would be to go to the user groups, but if they're watching this, they will have discovered the user groups, of course. Another advice would be to invest time not only on your project. Invest time in learning, like choose your percentage, but if you have to invest in your learning in order to have a good career.
All right. So with this being said, it's been great. I think it's we touched on a few very interesting topics. I hope everyone enjoyed this. I'd like to thank Johan for being such a wonderful conversation partner.
Thank you very much.
And yes, you want to say something else?
No, it's been wonderful discussing with you. It's always a pleasure.
Thank you, and we are coming back with new conversations soon. And until next time, well, first of all, we have to pay our dues to the algorithm, so please like and subscribe and comment and whatever we have to do so that YouTube notices us. And until next time, remember to think, design, and work smart.